Hello everyone. Today I will be starting my new series on layman terms. Now, in layman terms is basically just a series where I explain relatively difficult concepts to understand in as easy of a way as I can explain it. So not today. This will be split through like a multi-part series, but I'm gonna cover linear algebra right now. So basically, the core of linear algebra, or at least one part of linear algebra, is this thing called vectors. Now, what is a vector? A vector is basically just like a value, like a number, with a direction. So let's say this is like 9 inches and it's going that way. 9 inches is a value, and that direction, which we'll cover later, that is the direction. So that's basically a vector. Now, vectors, besides being expressed as arrows, can also be expressed as columns. This is just a normal two-dimensional vector with the x dimension and the y dimension 1 1. And this means that it's going 1 to the right, or 1 like in the 1 x equals 1 and y equals 1. Now, one operation that we can do with vectors is add them. So for example, 1 1 plus 2 3. And to add these vectors, you simply just add these numbers. Though the number on the first row of this one plus the number of the first row on this one equals 3. So 1 plus 2 is 3, and that goes on the first row like these other two. Same thing for this one. 1 plus 3 is 4, and it's on the second row. And adding vectors can also be shown by, let's say this is 1 1, and 2 to the right, 3 up would be like, let's say here, 2 3. We're adding 2 3 from the little arrow point of 1 1 to get 3 4. This doesn't look very good, but I hope it's understandable. And another operation we're going to cover is multiplying scalars, basically numbers without directions, by vectors. So a scalar is just 9. No direction, just 9. It's just a value. Now we can multiply scalars, basically just numbers, by vectors, like 9, 1, 2. And what we have to do is sort of like distribute it across these values. So this would give us 9 18, since 9 times 1 is 9, and 9 times 2 is 18. Now, when we combine those two operations, we get a linear combination. Basically, it's basically like a combination of vectors, pretty much. It's a combination of these operations. So 2 1 2 plus 3 4 1 equals. Now, to get the final vector, we would have to multiply the scalars. So we get 2 4 plus 12 3 equals 14 7. So now we multiply these and then we add them to get 14 7. Now we can show this by going 1 2, but twice, and then 4 1 3 times to get 14 7. And now, if we have just like one of these vectors, like 9, 1, 1, it lies along, or actually we could just do like a variable, basically something that can change. So C 1, 2. This lies along a line. So what that means is like 1, 2, for all values of C, it's always going to lie on this line right here. It cannot go outside because you can't exactly do that with just 1, 2. However, if we have two values, like, I don't want to erase that one. Let's say C 1, 2 plus D 2, 3. Here we get something that lies along a plane. So basically, we can have any combination